Hi, and welcome to this section of the Pre-Algebra Tutor. And in this section, we're going to switch gears from the fractions work that we've been doing recently. We're going to start getting into really what you would start to consider the nuts and bolts of algebra and pre-algebra. That's when we start talking about variables and expressions, and later on we'll get into equations and other things that you typically think of when you think of algebra. But we have to crawl before we can walk, and actually, believe it or not, in some previous sections I've sort of already introduced you to this a little bit as we've gone along here with some of these concepts. But here we're going to hit it, full force, and so give you the full force and really open it up to you and tell you what it's all about. So in algebra, a lot of times, and we've talked about this before, a lot of times you're solving for something you don't know. Maybe there's the speed of a baseball. You throw a baseball, you don't really know how fast it goes, maybe you drop something off of a tower, you're not sure how fast it's going when it hits the bottom, but there's some sort of expression or an equation or something that describes how fast that thing is moving, and so using the math you can sort of figure out what it's going to do in the future. And so by using different values of time or something, you can figure out what something's going to do in the future. So you have the concept of a variable, and that's just something you don't know the answer to right now, but it's something that you can solve for to find the answer for whatever problem it is you're trying to do. Maybe we're trying to construct a building. Maybe we want to see how strong that building is going to be. Maybe we're trying to build an airplane. The airplane has a certain amount of lift. We're trying to figure out how much lift it's going to have. That's a variable. We don't know what it is, but we set everything up and we solve the math to figure out what the answer is and solve for our variable. So a variable, because you don't know what it is, we represent it by a letter. You can use any letter you want to. You can use T for time, you can use S for speed, you could use V for velocity, but a lot of times in algebra we end up using X a lot, and that's just sort of by tradition. So in your books you'll see X and you'll see Y a lot, and you'll see T and you'll see Z, but you can use any letter you want. It doesn't matter, it's just a variable, it's an unknown number. But just remember, every time you see one of those letters, it's just a number that you don't know the answer to yet. So this section we're going to start dealing with what we call expressions, which are just things that we write down in algebra that involve variables. So let's get right into that. If I gave you an expression, and don't let the term expression bug you, it just means something we're writing down in terms of algebra, 2 times x plus 1. We write the 2 and the x next to each other because they're multiplied, so 2x plus 1. Now what if I told you if x is equal to 1, then what would this be equal to? In other words, here is something involving an unknown number. But then I went ahead and told you what the unknown number is. X is equal to 1. X could be anything. Could be the speed of a spaceship, could be the height above the ground, whatever you're solving for. But in this case, we know it's equal to 1. So what you do is, you just take it and you just plug it right back into its position in this little expression here. So we have 2 times x, but x is equal to 1. So we substitute the 1, and then we have to add 1 at the end. Now here's where your knowledge of order of operations comes. We know we have to do multiplication first. So 2 times 1 is 2, and then we still have to add this 1. 2 plus 1 is 3, and that's the answer. So in this section, we're going to be doing problems of this type, just to drill it home to you. You're given an algebraic expression. This is the thing with the variable, and I'm giving you the answer. I'm telling you what the variable is equal to. You need to calculate what the final answer will be, given that you know what the variable is equal to. And that's really all we're going to do in this section, just to get you comfortable seeing some expressions and so on. What if you had 2x plus 1, so same expression, but x is now equal to 2. So the variable, the unknown, is a different value than it was the first time. But you proceed the same way. Multiply by 2 because this x goes right into this spot, plus 1. 2 times 2 is 4, but don't forget we still have to add the 1, and in the end we're going to get 5. And that's the answer. What if you had 2 times x minus 1 is our expression, and let's say x is equal to 1. Do the same exact thing. You take it and you stick it in there. So 2 times 1 minus 1. From here, we're just substituting it back in. 2 times 1 is 2, minus 1. 2 minus 1 gives us 1. And that's the answer. Now, what if you had 2x, so 2 times x, plus 4, where x was equal to 5. So we've solved it. We figured out what the answer was. X, the unknown variable, was equal to 5. So what's that going to make this expression equal to? 2 times 5, plugging in for x, plus 4. 2 times 5 is going to give me 10, but I still need to add this 4. 10 plus 4 is 14. Now, one thing is, don't try to do too many steps at once with any of this stuff. You know, a lot of students can put this in there, multiply and add and get the answer, and just circle the answer on their test. But that's the wrong thing to do, because eventually you will make a mistake. If I give you negative numbers, if I give you a more complicated expression, you will eventually make an error, a sign error or some kind of math error. Happens to me, it will happen to you. If you don't write anything down, then no one's going to know if you have any idea what you're doing. So you really need to write out your steps. I'm not doing this for your benefit. This is, well, I am doing it for your benefit, but when I work these on my own, this is how I do it. I'm not doing anything special because I'm teaching this to you. This is how I do it. 2 times what I'm plugging in, write it down, plus 4. Next step, do the multiplication, but don't do the addition. Next step, do the addition. That way, if I make an error, and you will make an error eventually, you can trace back through and figure out what you were doing. But if you just sort of say, oh, 2 times 5 is 10, plus 4 is 14, okay, that's the answer. Moving on. Well, then you're never going to figure out the answer when you make a mistake. And believe me, it's just a matter of time. What if you have 2x minus 6, where x is equal to 3? Well, we just plug it in here. 2 times 3 minus 6. 2 times 3 is 6, minus this 6 is going to give us 0. That's the answer. What if you had 1/2 times x plus 5, where x is equal to 0? So I plug in x is equal to 0 in there. I'm going to have 1/2 times 0 plus 5. 1/2 times 0, anything times 0 is 0, plus 5. It's just going to give me 5. That's going to be my answer. What if I have 3/2 times x minus 3, where x is equal to 3? So I plug this guy in, so I'm going to have 3/2 times x, but this is just going to be times 3 because x is equal to 3. So I'm going to have minus 3. So how do I simplify this? This is where you start to need to use your knowledge of fractions. You have something multiplied by a fraction here. So you have 3/2 multiplied. 3 can be written as 3 over 1. Don't forget to keep your minus 3 to keep everything straight. Now you can do this multiplication very easily. 3 times 3 is 9. 2 times 1 is 2 minus 3. So you have 9/2 minus 3. And that really is the answer, but you don't want to leave an answer like that. You want to try to put it into one fraction if you can. 9/2 minus, this is just 3 over 1. Now you need to again use your knowledge of fractions to find a common denominator and do this fraction subtraction. So what we're going to have is 9/2 minus 3 over 1. Now what do we do to find the common denominator? If I can take this guy, multiply by 2, then I'll get a 2 in the denominator here matching this one here. This is exactly what I want to do. So what I'll have is 9/2 minus 2 times 3 is 6/2. So now I'm in a good position to finish the problem out. The top is going to be 9 minus 6, which is going to be 3. The bottom is going to be 2. So the final answer is 3/2, but actually that's improper, so I can divide that. 2 goes into this one time with 1 left over 2. So you can write it either way, 1.5 or 3/2, however you're more comfortable writing it. Some teachers will let you keep it in this form. Some teachers will make you convert it. But this was actually a problem that, you see where this is where algebra starts to get to be tricky for some students. If they don't understand fractions, that's why I keep saying it over and over again, then this problem is absolutely impossible, even if they kind of know what to do. Because as soon as you put this in here, you need to know what to do next. You have to know that in order to multiply it, you write it as 3 over 1. Okay, so you do that business. And then you realize, okay, now I'm left with this. How do I subtract these? Well, if you have no idea how to find that common denominator, you're never going to make any progress. You might know that you need to plug in the value of the variable, but you won't be able to go beyond it at all. Now what if we had 2x squared, 2 times x squared, minus 3 times x plus 5. So that's a nice long expression. we'll say x is equal to 3. But it's no different. It looks bigger, it looks uglier, but it's no different. We just take x and we put it in everywhere where we need to. So we have 2 times. 3 goes into x, so this is 3 squared minus 3 times x, which is 3 plus 5. So I'm putting x everywhere. I'm putting 3 everywhere where I see an x. So take it one step at a time. The inside of the parentheses is going to come first. I'm going to square this. 2 times 3 times 3 is 9 minus 3 times 3 plus 5. Now I can do my multiplications. 2 times 9 is 18 minus 3 times 3 is 9 plus 5. Now I just do my addition subtraction from left to right. So what I'm going to have here is 18 minus 9 is going to give me 9. Don't forget the adding to the 5 later. And then I'm going to have 14 as a final answer. And this is what I say where in some of these easier problems, a student can very likely calculate it in their head. But if you even attempt to do this in your head, you're just asking for trouble. Eventually you'll make an error somewhere. And you'll just, unless you have an extraordinary memory, you're just not going to be able to keep all this straight. So you really need to write every step down, because if I made a mistake here, I would be able to go back and say, oh, when I squared this, I did it wrong, so then I could fix it. But if I don't leave my steps in a nice trail, I'll never be able to figure out what I've done wrong. Believe me, no matter how good you get at math, you're always going to make errors, especially if you're doing homework late at night or if you're tired. X is equal to -1, because when it's late at night, you're tired, you're distracted, you're going to make a mistake, and you want to have your habits really set up well in those cases. So let's take x and stick it where it belongs. We'll have -1 cubed minus -1, because this is x, this is -1 going in there, minus 3. Now I want you to take a second and truly watch what I've done here, because this is another thing that students do a lot. Okay, x is the thing that's cubed. So to make it totally clear, I stuck the -1 inside of a parentheses and cubed it, so that I knew that whatever it was I was cubing is the -1 thing. Now over here, I have a subtraction of x. So this is from the subtraction here, but the x thing I stuck in parentheses right there. Let me show you how a lot of students write it so that you don't do the same thing. A lot of students will say, okay, -1, I'll say -1 cubed, and here I have minus, so I'll put a negative there, and here's an x, so I'll put a -1 here, and I'll do like this. If you try to write it like that, you're just asking for trouble, because there's 2 problems here. Negative you can kind of get away with, but eventually you're going to screw this up, and you're not going to do the right thing without the parentheses. Here you're really going to get into trouble, because when you do 1 cubed, if you don't cube it with that negative sign out in front, you're going to get the wrong answer. If you leave the negative sign here and then cube the 1, getting this is totally and completely incorrect. So you really need to make sure that when you're doing this stuff, especially when you have a negative number like this, that you want to wrap it up in a parentheses to show yourself and remind yourself that when you cube it, you're cubing the -1. So let's proceed. This guy is -1 times -1 times -1. So as a sidebar, you have -1 times -1 times -1. Now this -1 times -1 gives me +1. So I have +1 times -1. These 2 guys give you this, like that. But then this final one, -1 times +1, is going to give me -1. Okay? So if you do it the other way, you're very likely to get into trouble if you don't, especially if it's not a cube. If it's a square or some other power, you're going to get actually the wrong answer. So do yourself a favor, wrap it up in parentheses. So what we're going to have out here is -1. Now here we have double negative, negative. So we're going to get a +1 here. You can also think of it as -1 times -1 is +1. And we have -3. And so what we're going to have here, -1 plus 1, 0, minus 3. And so the answer we're going to get is -3. And this is the answer. So -3 is the answer to the whole problem. And you just need to really make sure, especially with negative numbers and things that are squared, wrap it up in a parentheses. What if you have 2x squared plus y minus 1? Now here we have 2 variables here. We have an x and we have a y, but don't get worried about that, because I'm going to tell you in this problem that x is equal to 1 and y is equal to 2. So it's the same thing though. You just take these variables and you put them in their place. So 2, and then here you have x is equal to 1. I'm going to square that, plus y. Y is equal to 2, and then minus the 1. So here things are simple. 1 squared is 1, so you have just 2 times 1, plus 2 minus 1. 2 times 1 gives us 2, plus 2 minus 1. And you can be tempted to do this in your head, but I prefer to show every step. 2 plus 2 is 4, minus the 1. Then you're going to have 3 as the final answer. 4 minus 1 is 3, and that's the final answer. So don't worry about it if you have 2 variables in your problem. Nothing is different. Nothing has changed. And just to show you something else, the variables don't have to be x and y. 2 times b plus 3. Variables can be any letter you want. Let's say a is equal to 3 and b is equal to 2. Put them in their place, same kind of thing. A is equal to 3, so I'm going to have 3 squared minus 2 times b, which is 2, plus 3. Okay, 3 times 3 is 9, minus 2 times 2 is 4, plus 3. 9 minus 4 is 5, plus 3 from here is equal to 8. So the answer is 8. So what we're going to have next is, let's say we have 3a squared times b. Let's say a is equal to 2, b is equal to 3. So we stick them in there, and what we're going to have is 3 times a is equal to 2, we'll square that, b is equal to 3, and there's just nothing there, it's going to stay like this. Next we'll have 3, 2 times 2 is 4, times 3. So now we can start multiplying. 3 times 4 is 12. We're still going to multiply by 3. 12 times 3 is 36. 36 is the final answer. Now what if you had something a little more interesting? All right, these problems that we've had here, there's really been no fractions involved, but let's say we have x cubed times y over 1 plus x. And let's say that x is equal to 2 and y is equal to 3. Could be any values, but I just want to give you some practice here. Let's stick it in here. X is equal to 2, we're going to have 2 cubed times y, which is 3, over 1 plus x is equal to 2. And so what we'll have in the top, 2 cubed is 2 times 2 times 2. If you think about that for a second, 2 times 2 times 2 is going to give you 8. You still have times 3 on the top. 1 plus 2, we can go ahead and add that. That's going to give us 3. Now, if you really are sharp here, you could do 8 times 3 is 24. 24 divided by 3 is going to give you 8. But you can also just cancel the 3's here because they're sitting here right in front of you, and so the answer is going to be 8. That's the final answer. Now, for our last problem of this type, let's do something kind of large. X plus y squared plus 3, and let's say x squared plus y, and let's say plus x over here. And let's say, for our 2 variables, let's say x is equal to -1, and let's say y is equal to 2. So what would we do? Well, we're just going to proceed as we totally have been doing before. So inside of here, we're going to have x is equal to -1. -1 plus y is equal to 2. This is all going to be squared, plus 3. That's all in the numerator. In the denominator, we're going to have x squared, so we'll have -1 squared plus y, which is 2. And over here, we'll have plus x, but x is -1. So we've written everything in their spot. Let's see if we can make some sense of this. Inside this parenthesis, we have to do that first. -1 plus 2 is going to give me 1. So I'm going to have 1 squared plus 3 over. I can work in the denominator separately. -1 times -1 is +1. I have plus 2 out here. I have plus -1, but I can sort of write that as -1. That's fine to do. Anytime you see a plus -1, you can just write it as -1. So over here, 1 squared is just going to be 1 plus 3 over 1 plus 2. We can go ahead and add that together, making 3 minus 1. We're going to keep over here. We can't do that yet. And so what we're going to have now is 1 plus 3 is going to give us 4/3 minus 1. So you might be tempted to stay here, but we know how to deal with fractions now. So let me switch colors since we've got the answer, but we just want to continue working with these fractions here. This is going to be 4/3 minus 1, which can be written as 1 over 1. So now that I have it written like this, you should be able to realize that you can take this fraction and multiply by 3 on the top and the bottom. So what I'll have is 4/3 minus 1 times 3 is 3. 1 times 3 is 3. And so on my final fraction will be a 3 on the bottom because I have a common denominator. 4 minus 3 will be 1. The answer is 1/3. I'm Jason. We've learned a tremendous amount in this section. We've learned about expressions. We've learned how to evaluate expressions when we know the value of the variables that we have. And really it's mainly an exercise in order of operations, because once you understand the concept, when you put the numbers in there, it's all going to boil down to how comfortable you are with exponents and parentheses and order of operations and with fractions, because a lot of times you're going to be dealing with fractions. It's going to be more and more prevalent. And that's why I spent so much time on fractions and so much time on order of operations. So practice your problems, get good at them, make sure you totally understand this material before moving on to the next. And so with each building block we move forward, building your skills one step at a time, you'll be just doing fine in algebra. And with these skills will give you confidence to tackle the more and more complicated material. And you'll find after a while that none of it's really complicated. It's just building your skills one after another.